previous lesson. Today we are going to look at the number system. Now, why is the number system so important? Well, because it basically teaches us to uniquely categorize numbers, and we are going to learn how to represent these different numbers on a number line. Now let's start with natural numbers. Natural numbers are denoted with the symbol n, and here is the set. We write it as n is equal to, and natural numbers start from the number 1, 2, 3, and we can continue to infinity. Natural numbers don't include zero, they don't include fractions, and they don't include any negative numbers. Our next set is called whole numbers, and we denote it with the symbol n and a small number 0 next to it. Now yes, you got that right, because whole numbers are all our natural numbers, but it also includes a 0. So we can write the set as n with the small number 0 is equal to, and we start from 0, then 1, 2, 3, all the way to infinity. Whole numbers don't include fractions, and they don't include negative numbers. Our next set is called integers and is denoted with the symbol z. Now we include in integers all our negative numbers. So we start from a negative number, then minus 3, minus 2, minus 1, 0, 1, 2, 3, and as you can see, they don't include any fractions. So next set is called rational numbers and is denoted with the symbol q. Now they are the more complicated ones because there's a couple of things that we need to remember. Rational numbers are all numbers that we can write as a over b. Now what does this a over b mean? We can write it as a fraction. So basically rational numbers are all integers, all whole numbers, and all natural numbers, because we can write a 1 as 1 over 1, we can write 0 as 0 over 1, we can write minus 1 as minus 1 over 1. So basically rational numbers include all of these numbers, but they also include recurring decimal fractions such as 0,3 recurring. Why? Because any recurring fraction can also be written as a over b as a fraction, because 0,3 recurring is a third. Now they also include decimal fractions that end. So it's important when a decimal fraction ends, we can write it as a over b. For example, 0,25. It stops right there. And we can write it as 25 over 100, which simplifies to a quarter. So any decimal fraction that n can be written as a proper fraction. Now we go to irrational numbers with the symbol q and with a little accent sign right there. Now basically irrational numbers is all the things that rational numbers are not. So we cannot write irrational numbers as a over b. For example, pi. Pi is a fraction, a decimal fraction. It's 3,14 and it continues all the way to infinity. So it's not a recurring fraction and it also doesn't end. And we cannot write pi as a over b. So basically, we have to remember that irrational numbers are all those weird decimal numbers that don't end and they don't recur. Then we go to real numbers. Real numbers are denoted with the symbol r. Now basically, real numbers are all the numbers we can write. So it's all rational numbers, it's all integers, it's all the whole numbers, it's all the natural numbers, and it's all the irrational numbers. Because if we had time, we can write pi all the way. But it's going to take you forever, but we can write it. So all of these numbers that you see here is called real numbers. So last one, non-real numbers. It's denoted with a capital R and a small accent sign. Now basically that is all our numbers where we want to square root a negative number, because if you try to do it on your calculator, you will see that your calculator will tell you it's an error, because we cannot get an even root of any negative number. So when we try and do that, we call it non-real. We cannot write that number, it doesn't exist. So even numbers are things like 2, 4, 6, 8, 10. So when we try and get an even root of a negative number, we call it non-real. Let's go and look at some examples. Now let's quickly practice what we have learned. Let's try the following. Which of the following numbers are rational or irrational? Now here we have a 5. Well, a 5 is going to be rational because we can write it as a over b. We can write it as 5 over 1 and it still means a 5. So it is rational. Then our next one is the square root of 9. Now that is not a number, it's still a calculation, and once we do the calculation we see that the answer is 3, and we can write 3 as 3 over 1, so it is rational. Then our next one is 0.24. This is a decimal fraction that ends, so we know that it's rational. Now let me just quickly show you. 0.24, we can write it as 24 over 100, and that simplifies to 6 over 25. So we can write it as a over b, and we have rational numbers. Okay, so next one is 1 1/3. Well, it's already written as a mixed fraction, so it is rational. And then we have letter E, which is minus 0.36. We can write minus 0.36 as minus 36 over 100 or minus 9 over 25. We can also easily see that it's a decimal number that ends, so it is rational. And then we have pi, and we know pi is irrational. Now let's try the next one. Write whether the following numbers are real, rational, irrational, integers, whole numbers, or natural. So we have minus 5 1/4. So this is a fraction. It includes a fraction, and it's also negative. So it's not natural numbers, it's not whole numbers, it's not integers, because none of those numbers include fractions. So this is basically a rational number, and because we can write it, it's also real. Okay, because this is written as a over b, so it's rational, and because we can write it, it's real. Next one, 0.1458. Well, it's a decimal number that ends. So we know that it's going to be rational. It's also going to be real. It cannot be integers. It cannot be whole numbers. It cannot be natural numbers because it's a fraction. And then letter C, we have the cube root of 27. Well, we don't see an actual number. This is a calculation, so we quickly do it. The answer is 3. And well, 3 is a natural number. It's a whole number. It's an integer. It's also rational because we can write it as 3 over 1. And because we can write it, it's real. And then the last one is 7,236,478, and it continues all the way. It does not recur, it just continues with no pattern, and it doesn't end because it continues. So it's going to be irrational, but because we can write it, it's also called real. I hope these examples help, and see you next time. Bye.